Patient needs 250 mils of packed cells over 4 hours. The NIV set, which delivers 20 drops per mil. What drip rate and drops per minute is needed? Right? The drip rate formula looks like this. Is the volume multiplied by the drop or drip factor divided by the total time in minutes. Right, so we're just going to fill in that formula. The volume required is 250 mils multiplied by the drop factor. That's the drop factor there, 20 drops per mil. 250 multiplied by 20. All over the total time in minutes. Well, we have 4 hours. So 4 hours and 60 minutes in each hour, so 4 by 60. Now we can start doing a bit of cancelling. Divide above and below by 10. Now divide above and below by 2. 2 into 2 goes once. 2 into 4 goes twice. So now we have 1 times 250 on top. So that gives us 250. And we have 2 times 6 below, that gives us 12. Now both of these are even numbers. So we can divide 2 into 12, we get 6. And we're going to divide 2 into 250, we get 125. 2 into 2 goes once, 2 into 5 goes twice, and 1 over, and 2 into 10 goes 5 times. So now we can do this short division here. 125 divided by 6. 6 into 1 doesn't go, 6 into 12 goes twice. 6 into 5 doesn't go, down to 0. Now we need a decimal point and a few zeros here. 6 into 50, 6 eighths, decimal point there. 6 into 50, 6 eighths are 48. So it goes in 8 times. Now I think we're just going to go to the nearest whole drop. So now that we've 0.8, this rounds up to 21 drops per minute. Or you could just leave your answer as 20.8 perhaps. Not sure about the rounding there. So, 50 goes in 8 times and 2 over. Yeah, 6, and then 6 into 20 goes 3 times, so on. 2 over. So, your answer could be 21 drops per minute. I'm not sure about these machines, you see, whether we set them for... a reasonable answer would be 21 drops per minute. Another reasonable answer would be 20.8 drops per minute. Rounded to 1 decimal